This is one of the things that I'm still really thinking about in high school. I've got strategies for numeracy. In fact, one of the things I did in my numeracy books was sort of, I think, kind of daring, where I was like, I think these are the 4 main addition strategies. I think these are the 5 main multiplication strategies that the kids ought to leave knowing. I'd welcome you to argue with me on that. I'm now coming out with, I'm researching, what are the strategies in algebra? You might even not know what I'm talking about if you haven't looked at my numeracy work. Well, so what does that mean, to develop strategy in algebra? To solve this equation, what if I asked, good, great, where is it? There it is. If I said, hey, I've got this equation, x times the quantity x plus 3 equals, pretty sure that says, oh, not that one. Hold on, I gotta think for just a second. Curse and swear. I know what I did. That's a Mormon swear word. Okay. I think I can do this from memory. Ready? If I gave you x times the quantity x plus 1 equals 5. Will you solve that for me? Whatever strategy you like best, go ahead and welcome. Just solve that one. Actually solve this one. Okay. I got people up here using the quadratic formula, so I was a little bit like, wait, I think, I mean, you could use the quadratic formula. That is a thing. That'll solve any quadratic equation, right? But I wonder if we could be more efficient. I wonder. So I'm going to look around and see what my students are doing, and then I'm going to purposely choose a couple people to share. So, will you share what you did? Kaya. Kaya?
Yeah, that's
Kaya,
right.
bring it.
I distributed the x.
Okay, so you got x squared plus?
Plus x.
Yep.
And then I moved the 5 over at the same time, so minus 5.
And then?
And then just factored x minus 3x plus 2.
X minus 3, x plus 2. So close. I wish I would have looked a little bit close. Hey, can you, when you're thinking about, can you factor that one more time?
Oops, sorry.
No, you're so close. Go ahead.
X minus, no wait, hold on. It's 5, isn't it?
Yeah, that's a 5.
So no, I can't factor.
Can anybody pick up where she left off? It's fine. She got us a great start. Great start.
5 minus 4.
Plus 5.
No, that's not what I meant. 1 minus 1.
Plus 5 minus 1.
Right? No, that's not what I said meant. I messed up.
Oh, this is what happens when I try to do it with my brain. I don't want it to be 6. I think I want it to be x minus 1. Sorry. Does that work? No. Okay. I'm a loser. One moment. Oh, so close and yet so far. This is what I meant. Nobody can see that, right? I wrote the wrong one down. I have 2. Okay. Moving on. It was late last night. X times x plus 4 equals 5. There. Now you see how good my memory is when I'm nervous. Oh, sorry. Okay, can we still use Kaya's strategy? For time's sake, we just run with me. If I were using Kaya's strategy, she would have done x squared plus 4x minus 5 equals 0, and that factors into x minus 1, x plus 5, and so the solutions are what? Negative 5 and 1? Is that right? Yeah? A fine strategy. Then I would have another kid share, and I didn't have time to look everywhere. So did anybody think instead like that? Did anybody think about something like a number times a number should be 5?
Yeah.
Okay, so pause for a second. If you didn't, could you? Okay, so right here, Stripe, tell me what you did.
So I looked at 5 and I knew I had 2 numbers multiplied together.
Yep.
And so the only 2 numbers that multiply to give me 5 are 5 and 1.
Are they?
Well,
Are those the only 2 factor pairs of 5? Come on, middle school teachers, where are you when we need you?
they're not. Negative 1 and negative.
Okay, so keep going. Good job.
So, but I first noticed that if I used 1, then if I let x be 1, then I had 1 on the outside and 1 plus 4 is 5, so 1 times 5 is 5.
Show enough. Yeah? So we've got one solution right now. We know that x equals 1 is one of the solutions. How could we find the other one? How did you, did anybody that used that strategy find the other one somehow? Find your way. Trial and error would be one way. So I'm actually, oh, you have, who are you pointing at? You were pointing. So I could try them all. I could try them all to see which ones works. Is there another way that I could think? Now, I'm not actually going to, do you have some? Go
Well,
ahead.
I mean, you need, if you think that the answer is positive, that your number on the outside and that sum on the inside are both going to have to be negatives. So,
Does that make sense?
Yeah.
If I've got 2 things times each other, I'm trying to change colors to something exciting. If I have 2 things times each other that have to be positive 5, either both of those factors have to be positive, or both of those factors have to be negative. And I would want to follow this up with one where the 5 was negative, so then I would go, oh, one's going to have to be positive, one's going to have to be negative. And I pull that out of students. Look how I just did that. And what's crazy is almost always, she's in the room. Almost always I can go, is anybody thinking about it like that? And one of them's like, you want to know what I'm thinking? I mean, that's the usual, no one's ever asked me what I've thought before. And I pull it out of what they're thinking, and we get this phenomenal mathematizing happening.